Welcome to this afternoon's webinar, which we are going to talk about the walkthrough in VexCode VR. I will be your moderator for today. So I think some of you already know me. I am Coach Faith. So I am recently added robotics educator and coach of Tech Nights Robotics. So now let's jump to our session reminders. First, may we request to type your complete name via chat here in our Zoom meeting for our attendance. So second, we also encourage you to turn off your front camera video. Don't be confused, for we will be muting your audio for us to focus on what Coach James is gonna talk about later. And lastly, during our question and answer, we will limit our communication with hand gestures unless you are recognized to address your questions, okay? So you may also submit your questions in the chat box on this meeting, and we will try to address it later. So next slide, for our session overview, we will have 40 minutes of presentation proper and 10-minute Q&A at the end, okay? So in total, we will run at mostly 50 minutes. So reminding you as well that you can also submit your questions via technightsrobotics.com, our official website, and or in any Tech Nights Robotics social media platform. So, and lastly, there will be a published webinar created like this walk. Okay, we will be having a tagish webinar created on our official YouTube channel. So please subscribe in Tech Nights Robotics YouTube channel, okay? So I think we are all set and ready to jump now to Coach James' presentation. All clear? Okay, Coach James, let's go.
Hi, Krens. Hi, Jekyll. I'm going to give you a walkthrough on what VexCode VR is all about. So let me introduce myself to you. I'm Coach James. I'm the founder and the program director for Tech Nights Robotics. And I'm currently now doing what I like doing, which is about teaching and giving you the idea of what educational robotics is all about. So we were able, Coach Faith and I were able to finish our certification for VEX IQ through our AC Foundation. We were certified. I'm also certified as a Google educator. All right, let me continue. VexCode VR, what is it all about? Why are we choosing this? Basically, VexCode VR is a very, very good tool right now, especially during this EECQ season or Extended Enhanced Community Quarantine. Why? Because it allows us to actually program our robot without really having a physical robot. One of the best features of VexCode VR is actually it's web-based. There's no software installation required. You don't need to install VexCode VR. You just have to launch the link vr.vex.com, all right? And VexCode VR is actually based on VexCode programming software that we're using to program VEX 123, VEX Go, VEX IQ, and VEX V5. So it's just almost the same, but this time, you don't need to open the VexCode programming software or VexCode blocks or VexCode text programming softwares, but all you need to do is just launch the web-based VexCode VR. Now, this VexCode VR has virtual robots that are pre-built. It means you don't need to build. It's already there. It uses some of which will fascinate you. It uses some great drivetrains. If you're just starter, drivetrains refers to the mechanical side of the robot, which talks about how it goes from one point to another. It talks about the wheeling system, the wheel itself, right? It uses also sensors to help us finish or navigate or complete or solve challenges. It uses pen features where you can draw through the art canvas by a created drawing. And also it uses electromagnet to interact with game objects in some of the challenges. There are also virtual playground that you're gonna have as you implement your programs or as you try to play the program you created. This virtual playground is actually 3D. So you can have an advantage of it by seeing virtual robots features. So there's an option for that. There's a top view for that, and there's a 3D view for that. So I'm gonna show it all to you in a bit or two. All right, so VexCode VR again allows you to program a robot without having to use a physical robot. It explores the different virtual playgrounds with your VR robot. I hope everything is clear by this moment. So I'm gonna go ahead. So this is what it looks like, the slide I'm showing you. So you have here the entire workspace, and you have your toolbars that actually you can use as you try to navigate through VexCode VR. All right. So moving on, let me discuss to you what amazes me so much about the pre-built robots that we have. All right, the VEX VR robot is equipped with sensors. So if you haven't had any knowledge yet what educational robotics is all about, basically educational robotics is about using all the concepts in science, technology, engineering, and math, putting it all together, building a connection between all concepts, and use it or apply it through the practical use of robots. All right. The robots we're talking about here are the robots that you and I can build. All right. But at this moment, again, we can't go really have a physical contact, or we can meet together. So we have here a pre-built robot to use from. Also, it is actually, again, as I've told you, it's equipped with sensors. You can see here an electromagnet, which actually uses a magnetic force to actually lift the disc that is used in a challenge. You have a down eye camera. You have a front eye camera. It has a distance sensor. So if you don't have an idea what the distance sensor is all about, so think with me like if you have an idea how bats actually uses their sonar, all right? They releases a frequency of sound wave that allows them to detect any other living organism or any other obstacle in front of them. That's the idea of the distance sensor. It is a sensor that is being used to determine if there's an object in front or wherever the distance sensor is actually attached to, all right? So the next one is a gyro sensor, the one I really like the most, all right? Gyro sensor is basically making a degrees angle measurement and the degrees angle data gathering for the robot, all right? The gyro sensor is built in here to set your turning. So it's easier to turn your robot here because there's attached gyro sensor to your pre-built robot, all right? These gyro sensors allow you to move 90 degrees, 180, 270, 360 degrees. So it's up to you to set, all right? It also has controls, which I will share to you in a bit. It has a pen, all right? The pen can be moved up and down. Once it's down, you are able to draw 4 colors: black, red, blue, and green, which allows you to have a creative way of programming things. It's up to you. How will you use it? Well, but I'm gonna show to you how you can try to use it, all right? In VexCode VR, there is only one robot, all right? And it is already pre-configured. This eliminates the need for a robot configuration or predetermined template project. Let me make you understand it further, all right? Through robot controls, the VR robot has the following controls. Number 1, a drivetrain with a gyro enables the robot, or this enables the drivetrain category of blocks in toolbox of the VexCode VR. What's that about? So it's easier to make your robot turn because of the gyro sensor, all right? Also, a pen drawing. All right, I'm gonna show each of the block to you. How will you be able to use it? A pen drawing features that allows the pen to be placed up to not draw or down to draw, which I said to you a while ago. An electromagnet to pick up the disc with metal cores. Now let me go through the physical attributes of our robot. It has 50 mm diameter, all right? It has a 50 mm diameter. So from this point of the front wheel to this point, the center of the rear wheel or the back wheel is actually 100 millimeter. All right, this 100 millimeter makes you an idea of how much travel your robot can do. All right, specifically when you're about to measure or try to start your programming for your drivetrain. All right, the VR robot's length, all right, from end to end, from here, from your front eye to your rear side of your robot, it's actually 133 millimeter. All right. Next, so we're talking about robot sensors right now, motor and encoders that are 360 per wheel revolution. So the 360 degrees here is not referring to the entire thing, this thing, all right? The 360 degrees here talks about what is the degree rotation of a wheel in one turn. So that's actually 360 degrees, so like a circle, all right? It's 360 degrees, all right? The front-facing eye sensor also acts like a distance sensor and returns the distance of a detected object in millimeter or inches. So you have two measurements that you can use here. Millimeter, a metric system of measurement, and inches, an English system. I hope you already have a previous knowledge of metric system and English system, which, by the way, maybe we could have an opportunity to make sure or give another class about what are the concepts that is being connected using VEX Robotics. So maybe we could do that online as well. So a gyro sensor that is built into a drivetrain clockwise is positive. So clockwise. So 0 degrees going this way, that's clockwise. All right. Going this way, it's counterclockwise. So if you want to go for 90 degrees towards your right, for the robot, towards the right of the robot, that's actually a positive number. But if you want to go turn to the left, all right, that's a negative number. Is that clear? All right. I hope that you understand the idea. Again, if you want to go clockwise, it's positive. Counterclockwise, that's negative. There are two eye sensors. One that is faced forward and the other one that is faced down. So you can detect what color is in front or what color is actually present by the floor of the field. If there is the color sensor that can also detect red, green, blue, or none, as I told you a while ago. So a location sensor that reads X and Y coordinates from the front center of the VR robot. Now, what is an X and Y coordinates? We're talking about X ordinates and Y coordinates. All right, this coordinates is actually found in your Cartesian plane. I hope you already have an understanding. And if you don't have, you can just search on Google what Cartesian plane is all about. But I'll show you later what is a Cartesian plane. And I'll give you a brief introduction how Cartesian plane really works. All right. So that's actually created, or a trivia for you. It is actually named after Rene Descartes. All right. The Cartesian plane is named after Rene Descartes. So let's proceed. First things first, all right? VexCode requires a supported browser. So if you're using Windows computers, you make sure that you are able to have, or you already have, or you already installed Microsoft Edge. Make sure it's in Chromium version. If it is in basic version, it won't be able to launch your VR. All right? You also have Google Chrome and Mozilla Firefox for Windows computer. For Mac computers, you can use Apple Safari, Google Chrome, Mozilla Firefox. For iPhones, you can use Apple Safari or Google Chrome. For Android, both tablet and phones, you can use Google Chrome. And for Chrome OS, you can have Google Chrome. VexCode VR is compatible with Microsoft Edge Chromium only. That's a reminder again, all right? So that's how you can launch VexCode VR. And it's available for everyone. It's free. All right, you can have an access on that. We already have emailed to you the link. I also, I think TechNice Robotics also emailed to you some of the activities that you can use that you can also print, maybe show to your parents, so you can work with it as a family. So it's kind of great, a great tool for everyone to enjoy this season of being together, especially when everyone is encouraged to stay home. All right, so stay home, take time to have good family bonding with your family, maybe use VexCode if you want. That's going to be amazing. All right. So how will you be able to launch? How will you be able to launch VexCode VR? Again, as I've told you, to launch VexCode VR, you need to go to vr.vex.com. And once you have been redirected in your browser, VexCode VR will automatically begin running. So let's get going. I'm gonna teach you some of the stuff right here, and there's more to it apart from this one. I'm gonna make sure we'll get back to this slide. So I'm gonna go switch to my browser so I can show you how VexCode VR works. All right, here we go. So as you launch your VexCode VR, it will show you this workspace. So let's have it here. You have your browser. I'm using right now Google Chrome. The link that made me launch VexCode VR, again, it's vr.vex.com. And we have here your menu bars, all right? This is the logo for VexCode VR. And you have here the entire menu bar right here. So you have your workspace here. And of course, you have your programming blocks area, all right, which you can hide, by the way, if you want just to read your. So here you go. You can hide it if you want to just to read your program, or maybe show it again if you're about to use the programming blocks. All right. The first icon I'll be teaching you right now is this global grid icon, which has 3 options of language. You have English, Mandarin, or Spanish. All right. So I also have here file option, or the file menu. So when you click file, all right, you'll see here new blocks project. When you want to start a new project, you click on new blocks project. Now load from your device list is actually allowing you to get previously stored or saved program. All right. So the next one is, I'll go ahead, try to click new blocks project because I want to create a new block. Open examples. All right. I'll share it to you in a bit. Please remind me, coaches, to share to them open examples. And then you have saved to your device. So it's just the same thing as load from your device. It will make you pop out another window where you can save your, again, organizing the folder or your files will be able to help you locate properly your project or your codes. All right. So I hope you're doing well with that. So let's try this. VexCode walkthrough. Let's try walkthrough part 3. All right. So that's the name of our project today. And when you name it, as you save it that way, you're going to have now your file saved already. So tutorials are list of videos that makes you understand. So as you play, for example, getting started, all right, show you how VexCode VR works. By the way, the activities I sent to you is the same thing as this one, all right? It's just so happened that the file I've sent to you or we've sent to you is actually already compiled together. So if you want to have, some students would like to have it printed because they want it to be like organized as a book. So it's up to you if you want to do that, and you can write on it as you plan how to go through your VexCode VR activities. But apart from that, let me show you this VexCode Robotics Knowledge Base. So if you click on this one, my computer is lagging. What's happening? So if you click on the VexCode or VEX Robotics Knowledge Base, you'll be able to go to STEM Labs, all right? The STEM Labs can show you, or this is the list of write-ups, or should I say articles that you can read on how to go through getting started VexCode VR, how to launch it, support browsers, which I discussed to you a while ago. We also have here VexCode VR playground features, dashboard, location details, coordinate system, all of that I'll teach to you in a bit or two. How to open and save project. I was able to teach you that a while ago. The VexCode VR activities and robot features. I'm discussing to you the activities right now. Robot features I've given to you a while ago as well. So you can go check it all out here. And if you want to share it to your friends or your relatives, it's up to you. You just give them the link of whatever I gave to you. And again, you can check this entire session uploaded on our YouTube channel. So if you want to check that one out, please hit subscribe, and the bell button will keep you posted on whatever we are about to upload through the YouTube platform. All right. So I'm gonna open this one up, but I'm gonna go back to VexCode VR. I think I'm done sharing to you the activities option or the activities menu tool. So here you can rename your project if you want to. All right, you can change the name. For example, VEX Robotics. So we were able to rename. So that's how you rename your project. And then you have your playground option. So you click on playground, it will launch and pop out another window. So this window right here requires loading. So in your windows, you have expand if you want to make the window screen bigger. You can shrink it back to this size that we have right here. And you can hide it if you want to put it aside first because you want to check out your program, the programs you are making. And of course, again, you have an option for the activities, which I showed you a while ago, and the close option. So the select playground option in the middle allows you to choose from different series of virtual playgrounds, such as you have art canvas, you have maze. I'm gonna give you a tour of that. So I can show it to you right now. So you have here the option grid map. Here, you can see here a 10 by 10 grid boxes. It's a square field. And right here is your pre-built robot, which we can have a 3D view of. So you click on the screen and then you can just navigate like this. So you can see where is it going. Or you can have the previous view, the top view that we had a while ago. So you also have here your measurements or indicators for your, remember I've showed you the encoders. I'm telling you, so you have the distance sensor where 1845, so that's 1845 millimeter from the origin or the middle point of your field. You have here heading 0 degrees, rotation 0 degrees because it's the reset. So the gyro is at 0 right now. So the front eye says object false because there's no object in front of it, or there's no color in front of it. The down eye says there's no object below the robot, or there's no color below the robot. The location is negative 900 millimeter and negative 900 millimeter when you're thinking about X and Y coordinates. And of course, the location of the angle. Again, I told you it's 0. The bumper, it's false, both left and right. All right. Again, you have bumper sensors in your left and in your right. So you'll know if there's an object beside you or there's something else. So let me give you the second playground, art canvas. Art canvas basically gives you a field with much more smaller grid boxes. It's like a graphing paper. Here is a grid or the art canvas. So it looks really the same. So if you want to restart, this option here is the restart of your robot, the pre-start. So right here in the art canvas, it makes you stay in the origin. We call this origin in Cartesian plane. So origin is the center of X and Y. So it's the intersection of a horizontal line and a vertical line, so across. So in the middle of it is called the origin. you'll see here in the encoder for location, 0mm and 0mm. So that's your location right now. I'll show you where you can access that using open examples, all right? So the next one is this maze. So this maze basically allows you to have this different kind of maze. There's really no wall, but instead it allows you to lift disc from one place to another, all right? So if your robot gets here, I'll show you later, if your robot gets there, all right, you're gonna have here a front eye with color green and down eye with color green. Front eye will have now true as an object because there's a disc right there. Can you see it? Let me show you. There, that's a disc right there. Clear? Let's go try the next playground, the wall maze, one of my favorite, right? I think on it. So basically, wall maze is a labyrinth. It's a maze, but it makes you go from one point to another that is labeled either letter or a number. So A, B, C, and D, and then 1, 2, 3, and 4. And you can find an end zone that is actually checkered, red and black. So can you see it right now on your screen? So how does it look like? So it looks like a maze. There's a wall. So there is a wall. You can navigate through again. For example, if you want to twist on how you do A, B, C, or D, question and answer. So the first one to get the robot to the right letter gets the point, for example. That's the idea. So for example, 1, 2, 3, 4 of the first one to program the robot to make it fun for you and your family. The next one is a number grid map, all right? So basically, a number grid map is actually composing of numbered grid boxes from 1 to 100. So you have an idea already. So you can, there's an activity using grid map, which you will mark numbers as you are advised. So, but I'm gonna give you another way of making it more fun by, well, you can learn, it's like Singapore math, all right? You're using manipulatives, but this time you're using virtual manipulatives. Instead, you're using VexCode VR. So here's our number grid map. Number grid map has 1 to 100 grid boxes. Again, I'm gonna give you one idea. So for example, you wanna program your robot by the multiples of 9. Your robot should be able to mark all the multiples of 9. So 9, 18, 27, 36. So your robot should be able to mark that. And the first one to finish that gets the point, for example. So that's the idea of how you will use grid maps. That's one. There's also an activity right there. Or for example, you would like to get the sum or the difference or the product or the quotient of a number. Just make sure it's within 100. All right, it's just limited to 100. Next one is this transport. These are new things, I think. Whoa, it's really a transport. So I think what you need to do here, so you have a castle. What you need to do here is to get the disc from the castle and move it towards the goal area that is actually associated with color, red, green, and blue. So you have how many discs? So let's see. Top view, you have 4 red discs, 4 blue discs, and 4 green discs, a total of 12 discs. The first one to, wow, it's gonna be a tournament to go, huh? You can go ahead, get the disc to its proper place, and the first one to finish and sort your robot autonomous programming will get to win the challenge. That's an amazing ad. So let's discover the last one, Castle Crasher. So maybe, so looking at its name, it's somehow, so what will you do? So you don't have here, in your robot, you don't have any claw. So I don't think you can pick anything. So maybe you'll just crash it since it's Castle Crasher. So just bring it down. So the object, for those who can't, who wants to do some more in their playtime, go destroy this castle. It's up to you. All right, so I think that's most of your playground. I'm gonna go back now to grid map, which I'll be using as I teach you simple programming. Again, this what I did not pick up on back from our previous classes. I'm just really, my goal today is just to give you how to use some of you won't be able to get everything. Let me share that again. Again, if you stay connected with us, you're gonna have more access on how we will teach you to use some, or how will you effectively use, especially the use of operator blocks, variable blocks, sensors blocks, or control blocks. All right. So let me start by showing you maybe drive forward. So what I wanted to know is I wanted to get my robot maybe 1, 2, 4 blocks away. So let's try how much is a 200 millimeter travel. So if you want to try this, you're gonna go just press start. So you would like to know how far can the robot go. Whoa, 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 whoa. Let's take a look one more time. Let's reset our robot. All right. So from the first box where we are at, how much is a 200 mm? So it's 1 grid boxes. So if I want 1, 2, 3, 4 more grid boxes, all right? So let me reset that. How will I do it? What will I need to do? How much measurement should I go for it? It should have been 200 multiplied to 4 because you want to go for a 4 boxes. Why did I say that? Because 1 grid box gives you 200 millimeter travel, all right? So 200 times 4 gives you 800. So let's try if that will work. And 1, 2, 3, 4. Congratulations, we're able to do this. So the next thing we want to do after driving 4 grid boxes forward, we want to turn to our right. All right, and then turn right 90 degrees. So again, with your gyro sensor attached to your robot, your 90 degrees turn to the right should be a perfect 90 degrees turn. Let's try it. Going forward, 2, 3, 4, and 5 should turn. Voila, perfect. And we want to go forward again, 4 more boxes towards the grid. But I want to go, let's go try to go to our origin here, our 0, 0 origin. So I'm gonna go add drive forward. So if 1 full box is actually 200 mm travel, I go for a half of it. How much should I add? So it's 200 divided by 2, you're gonna have 100. So I'm gonna make this 900, and let's see if it will go in the middle of the line. All right, that's our objective. Again, that's what we're trying to do. Let's try and see it. So we're using now drive block, turn block, and drive block again, and it should be in the middle. Boom! We're in the middle. You see X is equals to 0 right there in your encoders. You can see X is to 0. That's an idea. If I want to go in the middle, you see the Y giving me an ordinate of negative 100. So you can use that data and try to maybe make it 100 more forward. We'll make this robot turn left and then 100 millimeter more forward. So we'll try that right now. So turn left, we'll add this, and then drive forward 100. Let's see if we will be able to get to the middle of our field, our 0 X ordinate and 0 Y ordinate. Let's try that. And moving forward, 4 grid blocks, 800 millimeter travel, turning 90 degrees, and this time 900 millimeter. and then forward. Bam! We made it. So our goal area is 0 and 0 for our X and Y coordinates. We're now in the origin. We're in the middle of our box. So I was able now to teach you how to use basic drivetrain tools. All right. So there's also, for example, I want to use now velocity. So let's, for example, set velocity. What I want to do is set velocity to maybe 100. So we're using now drive or set velocity. So we're looking at after 4 grid boxes, as it turn right, it will now make the robot increase its speed. All right, when we set the velocity from 50% to 100% right now. Let's see how does work. How does that work? There. Boom. You see that? So it's working. So set drive heading. So if you want your robot to have the degrees set, you can set it here. Magnet, energize, or magnet. So magnet is actually for, you see this? When you boost it, all right, the option. When you boost it, the disc will attach to the magnet. Boom. And then when you have it energized to boost the magnet, and when you set the program to drop, so remember what do you call that playground a while ago? I think this is the best. This is a new programming block they added also. Maybe you can use it for this transport or for this maze. So it's up to you. So when you boost the magnet pump, all right, it will attach now to the robot, and then boost it or drop it, change boost. So for example, when you add this one, drop it, you will drop now the ano. By the way, all right, one of amazing tool of this VexCode VR is actually the help option right here, all right? So if you click just click one, boom. You'll see the help option now will show you or tell you, define for you, what is that block, programming block, and how will you be able to use it? So this is what I'm trying to tell you. So this is an example. We'll set the robot to drive forward. Magnet will boost to pick up an object, drive forward 200 mm, and then drop the object. So that's the idea. So you can explore that on your own. All right. Let me go through now the looks. Again, you can use help if you want to understand more what that programming. You can also enhance your skills in programming by making sure you're connected to us, connected to TechNights Robotics. We're going to give you different kind of classes virtually or through video conferencing. Tell it to your parents. Just watch out. Give us a feedback. Give us a recommendation. Answer the survey. We will really appreciate that. Going back to the looks. All right, we have here looks, robot pen. Again, the use of robot pen, I'm gonna erase. By the way, that's how you erase a program. So for example, you put it here in the workspace and then you click it back and drop it there, it will be erased. So using the looks, you can now draw a line. So you have to move the robot pen down so it can draw something. And you can set the color of your pen. So if I'm gonna reset this, it should be able to draw a line from here to the middle, right? So let's try it. There. So you see the blinking? That's also a new additional feature of VexCode VR. So it will tell you the blinking green block shows you what program block is working at the moment, all right? So that's your looks. So you see the line. How about, let's try draw an X. How about let's try draw a cross using that red. How about we try drawing a cross? So to draw a cross, what I'll be doing is just to show you, It's gonna be quick right now. I want it 900 because I want it in the middle. So it will go 900 for around, all right? So what I want to do is to have a vertical line that is, or a horizontal line that is about 450. So what I wanted to do is change this to 450. So from 450, I'm gonna drive again, 450. I'm gonna do it 900, right? So it will go across to the other side. So let's see if it works, all right? So it should go from here, it should draw a line from here to here, or maybe I'm wrong. Draw, is that it? Yeah, I'm correct. That's it. So I want it to go back. So I'm gonna move my robot pen up. I think no need because I'm gonna use the same pattern. So what I'm gonna do next, instead of moving my robot pen up, I want to turn about, all right? To turn about, so turn heading, I'm gonna use this turn to heading. For example, I wanna go turn, that's 180 degrees because that's a half of a circle. So my robot should be able to turn, and then I want it to move forward, drive forward 450 degrees. And then, so it will go forward in the middle, and then I want it to turn right. So I'm showcasing you now. How will it be? So I want it again to drive forward 450 degrees. So I'm showing you, I want to draw across because we just had Resurrection Sunday. It's amazing to have it. So you'll go drive forward 450. So let's try it. It should be able to create another one right here. All right, one more time. So it creates now my horizontal line. Is it creating the same thing? Oopsie, what happened? Whoa, what happened right there? Turn heading. Oh, I forgot. The 180 degrees is set to 0. So I was wrong about that. So let's try do that right now. So it's faster. And we go boom, turn. All right, it's working. And then go up. And what we want to do is again, turn right again, 180 degrees. And I want to go, instead of 900, I want to drive forward for about 1,200. So let's see, how will that work? All right, let's reset. Are we able now to create our cross? So let's see. So it's drawing now. It's like an art canvas. There. And going back. Boom. There. So I think we're done creating our basic cross. All right. So you have here controls that you can use. So the controls are for waiting if you want your robot to wait. So you have your repeat block if you want your robot to repeat whatever you're doing. So I want to save this first. VEX Robotics Cross. Let's rename it that way. And then we'll try to save it. So I'm showing you now how to save it. So again, you have your controls you can use forever if you want your robot to do the same program over and over again, or maybe a limited number, use the repeat block control, all right? And then you're gonna have your limited number of repeating for your project. Or you can use conditional statements such as if and then. So this shape allows you to have an idea that you can insert a hexagon shaped programming block. So if, for example, a sensor like this one, driver is done, or drive is moving, or maybe use a bumper pressed, or if the bumper is pressed or another sensor is used. So it's up to you. Or what else? It means you can put it inside or within. So let me show you how will that work. All right, let's go for a new project. So I'm just gonna show you how things are. All right, so for example, I'm using if this one. All right, so again, if it is shaped as hexagon, you can put it there. All right, so if the distance object or the distance sensor found an object, you can put it right there. Right, then the robot should be able to move forward. For example, just for an example, or if the front eye is near an object, you can use that at the same time as well. So by the way, you can put it on the side and then you're good to go. Positions, it's right there. Operators, you can use, for example, all right, how can you incorporate operators? All right, then, for example, drive forward, and drive forward. You see the oblong shape field here that you can input the number. You can put their operators if you want, for example, there. So anything that is circular. By the way, the use of this, it will require you time of practice. Also, maybe I cannot teach you all of that right now here because that's already operators, all right? But please watch out and please stay connected with us. We're gonna give you a class about how to use the operators or how to use the variables. How will you set the variable, which by the way, you can set, all right? Like this one. So for example, you set your variable in the beginning of your robot to 100, all right? And then you have your my blocks, so you can create your own block, name your own block if you want, all right? So if you want a text that is added to it, for example, you can name it your block. So make a block your way, so it's up to you. So you can check how will that be used through your help option. Click on help option. I'm gonna hide this one right now. And I'm gonna put it aside, click block name, and you'll see how you'll be able to use it, all right? So that's basically it. And we have here the comments. What is comments? Comments basically is giving you an idea or allows the programmers to write information to help describe their program. So whenever you create a long lines of programs, all right, you want to organize them per pace. You want them to be in a group where the robot performs a particular task. For example, the robot picks up an object. That's one robot picking up an object. And these are the series of my program, for example. You can have a name on it. Again, a comment block does not perform anything. It doesn't do anything. It's just giving you a planning or an organization of your programs, all right? So how will you be able to use it? So drive to wall, for example, right at this one I'm showing to you. So that's basically it. That's all you need to learn in how to actually navigate through VexCode VR. By the way, I asked my coaches to remind me. I reminded myself about using open examples. Let me show you. Open examples gives you a wide variation of how you will be able to understand using VexCode VR. By the way, you have here all of them in the list, but you can actually have here a filter of things you can do. For example, adjusting drive to turn velocity, change drive velocity, move forward and draw a right angle. So it's up to you. You can check it out by clicking. For example, you click one. I'm gonna discard what I'm currently working on because I don't need that right now. I'm just using that. So this one that appeared right here is actually telling you how to, using your option here, open examples, it tells you how to draw a right angle. So if you try to play what's already here, I can show you right here. So I'm gonna go reset that one. So there, that's a right angle. All right, so you have red and green being used as your art canvas. And you can explore some more. By the way, the open examples contains a lot like the use of variables, operators, sensors, and again, the control I'm telling you. Basically, that's all you need to know for basic programming. I hope I was able to get to you all the details you need to learn. So if you're listening through YouTube channel and you're watching this replay, please check out our www.technightrobotics.com. You'll see what we're all about, what are we offering, and how are we doing it, who are our partners, what are the things you can learn from us, and how can we partner together in having your educational robotics learning journey. All right. We also have the Facebook page, facebook.com/TK Robotics. We also have Tech Nights Robotics in Instagram. And again, our YouTube channel is actually Tech Nights Robotics. Subscribe and please click on the bell button so you can just be updated on the videos we're gonna launch. We're gonna launch a lot in the few more days coming. We're gonna launch a different platform for understanding programming. We're gonna launch how we should be connected as learners. We're gonna launch tips on making you have more attention or helping your parents how to do homeschooling. We're gonna do a lot in the near future, and it's great that we're doing this. We're partnering. We're not competing with nobody. We're just doing it, growing together, building things together, making better together as we progress in the future. Again, this is Tech Nights Robotics, inspiring the future through building robots. And our mission, bring educational robotics to where our learners are. Right now, in EECQ season, we want to bring Tech Nights Robotics at the comfort of your home through this virtual video. So again, check us out, get connected, stay connected, follow us. Thank you. Let me give an opportunity for our coaches to say thank you and goodbye. Bye, everyone.
Thanks, guys.
Thank you.
Bye.
Thank you again.
Thank you. Bye.
For
Bye.
joining us.
Bye.
Luis, thank you for joining us.
Thank you.
Thank you, everyone. Please students. God bless you. Bye.
Bye. Bye.
Bye.
Bye.